In this lecture, we're going to learn about some weird integral types. And what do I mean by this? Well, if you look here, integral types less than 4 bytes in size don't support arithmetic operations. And these are operations like addition, subtraction, multiplication, division. You can do these operations on those types. And here I have an example of some of those types. We have a car. It is 1 byte in size, and short int is 2 bytes in size on most processors. So you can't do arithmetic operations if your integer value is stored in these types. Why is that? Well, this has to do with processor design, and they decided to choose int as the smallest type, integral type, for which they can do these arithmetic operations. But compilers are really smart enough to notice if you are trying to do arithmetic operations on these types, and they are going to implicitly convert from these smaller types to int. And this is something you need to be aware of. If we look at this program here, for example, we have var1 and var2. They are stored in variables that are of type short int. And we have var3, var4, which are stored in a variable of type char. We can try and print the resizes, and we're going to get 2, 2, 1, 1 for these variables because a short int occupies 2 bytes in memory for my computer here, and the char occupies 1 byte in memory. But the catch is down here. If you try to add them up, the result is not going to be the same type as the things you added up, and you would expect auto to deduce to the same type as var1 and var2. And it's not. Result is going to be an integer because int is the smallest type for which we can support these arithmetic operations. So if we print size of result 1 and result 2, we're going to get 4. But this is the behavior you're going to get, and we need to be aware of it. The same behavior can be observed on other operators that we will have a chance to look at in a few chapters ahead. And these are called shift operators. You use them to shift bits. But I don't want to talk any more about them because we're going to have a chance to learn about them in detail. Okay, now is time to head to Visual Studio Code and actually see this in action. Here we are in our working directory. We are going to copy our template project. We're going to copy this. Quickly put that in our folder on weird integral types. This is our current project here. And we're going to open this up in Visual Studio Code. We're going to open this up, and we're going to open our main CPP file, remove whatever it is we don't need. And we are going to put in our code. This must be very familiar because it is what we just saw in the slides. So what we are doing here, we have 4 variables. var1 and var2 are short int, so these are going to take 2 bytes in memory on my computer here. And char is going to take up 1 byte. And we're going to print the resizes. We're going to see them printed out. And we are adding things up here. We are taking 2 short int variables and adding them up. So what the compiler is going to do, it's going to take this, turn it into an int, and then do addition, and the result is going to be an int. The same story is going to happen for result 2 here. var3 is a char, so it is 1 byte in memory, but the compiler can't really add up integral types which are smaller than 4 bytes in memory. So what is going to happen? var3 is going to be transformed implicitly behind the scenes to an int, and var4 is going to be transformed to an int, and then we're going to add that up. And we're going to store that in an int variable, which is result here. If we print this up, we're going to see that size of result 1 and result 2 is 4. And this is what we expect here. And this is a behavior you need to be aware of because sometimes your application logic is going to depend on the size of data. If that's the case, you need to care about this. And if you don't know this, you're going to be bitten by this. And it is really hard to find problems like this. So what we can do is open up our terminal, and we're going to build this with GCC as we usually do, and we can run our program rooster, and we're going to see that this is what we expect. var1 is 2 bytes in size, var2 is 2 bytes in size, var3 and var4 are 1 byte in size, but our result is 4 bytes because the compiler implicitly converted our operands here to nths to be able to carry out this arithmetic operation. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to try and recap what we saw in the chapter.